Hello, welcome back to episode 3 of Spanning Tree. Episode 3, I'll be uh, talking about root port election. So, we'll be doing a lab on root port election. So, we'll see how root ports are elected and what are the things are considered for root port election. And we'll see that on the CLI. So, the first thing, right now the spine is the root bridge because in the previous episode, we done that. So right now the spine is the root bridge. So after the root bridge election, the next election is the root port election. So all the non-root bridges now must elect one root bridges. So leaf 1 and 2 are non-root bridges because they lost the election to the spine. So spine is the winner. So all the losers, basically the non-root bridges, must elect a root port. So the root port is the best, let's say, best port to reach the root bridge. So it is the best port. So this it is based on the cost. So whichever port has the lowest or least cost will become the root port. And if there is a tie there, then the next criteria is the bridge ID. If there is a tie there as well, then MAC address. If there is a tie there as well, then it is port ID. So these are the criteria. So I have detailed all these in my blog. You can read my blog. So now let me come to the topology. So leaf 1 is a non-bridge. Now it has to elect a root port. So it has three paths to the root bridge. So it's the spine. Spine is the root bridge. So path 1 is via ET1 and path 2 via ET3 and path 3 via ET4. So leaf 1 has three paths. So now three paths to reach the root bridge. So now it has to select one as the root port. So uh, to reach the root bridge via ET1, the total cost is 20,000. So it's 20,000. So let me tell you. So the root bridge sends BPDUs. So in that BPDU, the root bridge sends the root cost of zero. So the root bridge sends zero. Then when leaf 1 receives this BPDU on ET1, it will see zero. Then it will see the local cost. I mean the cost of ET1. So it will add whatever the cost is receiving plus the local interface cost. Basically, spine is sending zero and it is receiving on ET1 and the cost of ET1 is 20,000. So 20 plus 20, 20 plus 0 is 20. So that is the cost to reach the spine via ET1. And ET3, the total cost is 20 plus 20, 40,000. So spine is sending zero. So leaf 2 receives it and adds the local cost, which is 20,000, and sends this 20,000 to leaf 1. Leaf 1 receives 20,000 and adds this local link cost, which is 20,000. So 20 plus 20, 40,000. So now to reach the root bridge via ET3 and ET4, the total cost is 40,000. So the clear winner is ET1. So right now ET1 is the root port. On leaf 2 as well, ET1 is the root port because to reach this root bridge via ET1, the total cost is 20,000, and ET3 and 4, the total cost is 40,000. So ET1 is the root port on leaf 2 as well. So first, what I'm going to do is, first now, the first deciding factor is the path cost. So, okay, what I'm going to do is right now, ET1 is the root port because it has the lowest path cost, which is 20,000. So I'm going to change this. So what I'm going to do is I'm going to change this to 40, which is equal to ET3 and ET4. So ET3, the total cost is 40 to reach the root bridge. ET4, the total cost is 40 to reach the root bridge. And what I'm going to do is on ET1 also, I'm going to configure the same cost. Okay, I'm going to configure the same cost, which is 40,000. So then both ET1, ET2, I mean ET1, ET3, and ET4 will have the same cost, which is 40,000 to reach the root bridge. Okay, so then we'll see then we'll see which port is the root bridge, whether the ET1 remains the root bridge or ET3 or ET4 becomes the root bridge. Root port. We'll see that. Let me go to the CLI. So I already done the show spanning tree output. So we can see spine is the root bridge and leaf 2, ET1 is the root port. The reason is it has the lowest cost, which is 20,000. Here you can see the lowest, the cost 20,000, and the port is 81. So ET1 is the root port. The reason is it has the lowest cost, which is 20,000. Here also we can see ET1 is the root port, and here we can see port is ET1, and the cost is 20,000. Okay. So what I'm going to do is, let me do the watch command on. Okay. So I'm doing watch command, which is watch command for show spanning tree for spine and leaf two. So now what I'm going to do is, I'm going to go to interface Ethernet one on leaf one. So right now we can see that ET1 has the cost of 20,000. So I'm going to change this to 40,000. Spanning tree cost. So I can so the minimum that I can configure is one, and the maximum is two. Too many zeros. So cost, I'm going to save 40,000 now. So now all three interfaces on leaf one will have the same cost path, root path cost. Okay. Enter. So now the spanning tree is converging. We can see that there is a change on leaf two. So we'll come to that in the next video, why ET3 and ET4 responded to this change. We'll see that in the designated port election, which will be in the next video, which will be episode 4. So now show spanning tree. So right now we can see that the cost has changed to 40. We can see the root cost is 40,000, and ET1 is still, it remains the root port. ET1 remains to be root port. So now let me go back to the diagram and we'll do. So right now leaf one still has three paths, and all three paths have now same 40,000 cost. 40,000, 40,000 cost 20 plus 20. Now ET1 remains the root port. The reason is because ET1 is receiving superior BPDU than ET3 and ET4, because now all three interfaces have the same root path cost. The next tiebreaker is the bridge ID. Okay, so spine is sending the bridge ID of 0, and leaf 2 is sending the bridge ID of, which is 32,768. So both ET3 and ET4 are receiving 32,768, and ET1 is receiving 0. Also MAC address is also receiving 01. Here the MAC address is 73663. So ET1 is receiving a superior BPDU. So it still remains the root port because it's receiving bridge ID. So when ET1 is receiving 0, ET3 is receiving 32,000, ET4 is also receiving 32,000. So ET1 is still the root port. Okay, so next what I'm going to do is, because it is directly connected to the root bridge, and root bridge has the best BPDU in the entire L2 network. In the entire L2 network, root bridge has the best BPDU. So ET1 is receiving that best BPDU. So nobody can beat ET1. So in terms of MAC address and bridge ID, ET1 is receiving the best that is possible. So next, what I'm going to do is, so even though all three have the same root path cost, the next deciding factor also, ET1 has better, is receiving better bridge ID and better MAC address. So what I'm going to do is, I'm going to make this to 50,000. Right now it's 40,000. I'm going to change this to 50,000. We'll see what is going to happen. So let me change that to 50,000. Let me go back. So right now it's 40. I'm going to change this to 50,000. So now spanning tree should converge again. So show spanning tree. Now we can see ET1 has become alternative and ET3 has become the root port. The reason is we can clearly see that ET1 has the cost of 50,000 and ET2 has the cost of local cost of 20,000. And here we can see the cost, root path cost 40,000, and who has it? ET3. So Ethernet 3 has 40,000. Now there is one more thing. Right now, if you, some of you might have this doubt. So right now, Let me go back to the drawing board and diagram. So path 1, 50,000. So it is losing this to ED3 and ED4. So because ED3 and ED4 they have 40,000. So ED1 is out of the game. Okay. Now you might be asking, ED3 and ED4 have the same path cost. Okay. Then why ED3 is the root port, not ED4? Let me explain why it is happening. So there is a tie in terms of root path cost. ED3 and ED4, they are tie. Now the next deciding factor is the bridge ID. So since ED3 and ED4 are connected to the same switch, both are receiving the same bridge ID and same MAC address. So there is also a tie right now. So there is a tie in terms of bridge ID and MAC address, because ED3 and ED4 are connected to the same switch. So it's receiving the same bridge ID and same MAC address on both interfaces. Then the next deciding factor is the port ID. So let me show you that ED3 has the port ID of 128.3 and ED4 has the port ID of 128.4. So ED3 is receiving 128.3 and ED4 is receiving 128.4. So ED3 says, I am receiving lower port ID. So I'll become the root root port. So ED4 is losing to ED3 because it is receiving higher port ID. Let me show you. So we are also going to manually configure the port ID, and we all will also do that as well. So right now you can see the port ID. This is the port ID. That's 128.3. So ED3 on leaf 2, ED3 has the port ID of 128.3 and ED4 has the port ID of 128.4. So ED3 is receiving 128.3. So it is the root bridge. So what I'm going to do is watch one show spanning tree. So now what I'm going to do is I'm going to change this 128.2 from 1 to 128 to higher number. So I will configure higher on ET3 so that ET4 will send lower port ID to ET4 on the leaf 1. So ET4 on leaf 1 will become the root port because it will receive a lower port ID. Or let me do something. I will configure a lower port priority on ET4. So I'm not going to change anything on ET3. I'm just going to change it on the ET4. So I will configure lower port, I would say lower port priority on ET4, so that ET4 will send lower priority than ET3. So ET4 will become the root port. So let me stop this interface ET4. So now spanning tree port priority. So I can configure a port priority. The lowest is 0 and the highest is 240, and it is in the increments of 16. So I can configure lowest priority of 0, but I'm not going to do that. So I'm going to do something like, so 128 minus 16, which is 112. So I'm going to configure 112 on ET4. So as soon as I enter, now ET4 on leaf 1 will become the root port. Okay, so watch out for the change in ET1, sorry, ET4 leaf 1. So watch out. So keep watching leaf 1. So I'm going to enter now. So now we can see that, yeah, ET4 has become the root port. The reason is show spanning tree. The reason is right now ET4 has lower port ID, or let's say port priority. So it has lower port priority than ET3. So right now ET4 is sending lower. For example, what is happening right now is ET3 is sending 128, ET4 is sending 112. So this ET4 says I am receiving lower port priority or lower port ID. So I will become the root port. So ET3 is losing to ET4 on port ID. So they have the same root path cost, same, they are receiving the same bridge ID, same MAC address, but they are receiving different port IDs or port priorities. So so now we have understood how, spanning tree root port election happens, and what are the things, what are the criterias are considered for root port election. So what I'm going to do is I'm going to do some tests here. So I'll also do what. So I'm going to do TCP dump on root port, and I will also see what is happening on the root port as well. So first, what I will do is let me remove this priority. Then ED3 will become the root. So I'm going to do watch again this. And let me remove the interface Ethernet 1. So let me remove the 50,000 as well from here. So now ET1 should become the. So now I have reverted all the changes I made. So now ET1 is the root port. So now what I'm going to do is I'm going to see what happens when root ET1 goes down. Okay. So what I'm going to do is I'm not going to change anything here. So I'm going to go to the spine. I will shut down ET1. So what I will do is right now I will shut down ET1 and we'll see what happens when a root port goes down. Okay. So I'm going to create a scenario like what if my root port goes down? Okay. So interface Ethernet 1. So show LLDB neighbor. So we can see ED1 is connected to leaf 1 Ethernet 1. So I'm going to shut it down. Okay. So when I shut this down here, ED1 will also on the pair also the ED1 will shut down. Okay. Now then some other interface should become the root port. So we'll see that. So I'm going to shut down. So now spanning tree is reconverging. We can see that. Now we can see ED3 has become the root port. ED3 has become the root port. The reason is because the actual the root port is down. For some reason, the root port is down. So now ED3 becomes the root port and it is forwarding. If ED3 goes down, then the next best will become the root port, which is ED4. I will also do that as well. Interface ED3, I will shut down. Now ED4 will become the root port. Now we can see ED4 will become the root port. Okay, so that's how spanning tree maintains this loop-free topology. So there will always be a root port. So the root port will is the best path to reach the root bridge, and root bridge is the central reference. So all the non-root bridges will have a one root port to the root bridge. Okay, so one interface will become the root bridge, and all the other interfaces, the redundant, let's say these additional or extra interfaces, redundant interfaces, will be blocked. It is either on one side, one end will become designated, the other end will become alternative. So that's how spanning tree maintains loop free topology. So let me unshade. Okay, so what I'm going to do is I'm going to do the watch again. These. So let me also now shut here. So what I'm going to do is so on the I'm not going to do anything on the spine. Let me keep the watch command on the spine. So I'm going to go to leaf one. I'm going to do TCP dump. TCP dump interface Ethernet 1. So I'm going to do TCP dump on a interface 1 and we'll see. So what is happening on the root port? So we'll see what are the packets or traffic going through the root port. So ET1, we can clearly see that 01 MAC address 01 is the root bridge. So ET1 is receiving BPDUs. These are BPDUs. So we can clearly see that we are receiving BPDUs, and there should be some LLDP package as well. We should be seeing both PPDUs as well as BPDUs as well as LLDP. Yes, yes, I can see some LLDP here, some LLDP activity I can see, and the rest is ET1. So ET1 is only receiving. So the root port is only receiving. Uh, it's only receiving BPDUs. It's not sending any BPDUs at the moment. So it's only receiving. And LLDP, let me see whether yes, LLDP is D980, I can see, and 3684. So LLDP, I can see from both leaf 1 as well as spine. So LLDP packets are going both ways. I can see bidirectional. For LLDP, I can see bidirectional. But for BPDUs, I can see only unidirectional. So only spine is sending BPDUs. So the leaf is not, the root port is not sending any BPDUs. But what I'm going to do is, let me go to leaf 1, interface Ethernet 3. So I'm going to shut down interface Ethernet 3. Shut down. ET3 is shut down. And okay, still going through. We are not seeing, the root port is not sending anything. Okay, now interface Ethernet 4, shut down. So the root port is not sending anything. Okay. Remember one thing, ET3 and ET4 on leaf 1 are designated ports. Okay. So let me know chat. So leaf 1, yes, we can see one thing. look here, there is this topology change. So let me stop this. So there is this topology change. The MAC address is D984. So D984 is sending a BPDU. So we can see that 3648, that's LLDP. Okay. Let me see D9. Okay, that's LLDP. So D984 is sending a topology change. So that's TC flag. So it sends a BPDU whenever there is a change. So what happened? I shut down this ET3 and ET4 and no shut it, right? So it created a topology change. So because when I no shut it, the interface ET3 and ET4 on leaf 1 became the designated and forwarding. So there was a change. So so this root port actually sends BPDU when the network changes, when the topology changes. Root ports do send BPDUs, but in a normal scenario, they don't send BPDUs. But when a change happens, they do send BPDUs. So let me see that here as well. DCP dump interface Ethernet 1. So I'm just going to do it for STP. So on leaf 2 as well, I'm doing it on the uh, root port. So ET1 is the root port, and we can see root port is only receiving BPDUs. Root port is only receiving BPDUs. It's not sending any BPDUs. Okay, it's not sending any BPDUs. But let me see interface Ethernet 3 and 4. Let's see if I shut down ED3 and ED4 on leaf 1. Let's see whether it is sending any BPDU. Let topology change BPDU. Okay. Okay. It's not sending anything now because I just shut it down. So if I no shut it, it should send a. Let's see whether it is sending. Yes, there is. We can see topology change. So topology change. You can see. So root port does send BPDUs. So actually, it's not sending BPDUs. So this is from the root bridge. Root bridge is actually sending the BPDU. Let me do one thing. So what happens? So let me go to the topology. So what happened just now? So when I shut down these interfaces, so ET1 sent a BPDU with topology change. So spine is the root bridge. It receives this BPDU, the topology change. Then it sends, it's already sending BPDU. So in the BPDUs, it just enables that TC flag. So it sends that TC to other non-root bridges. So leaf one sends, when leaf one detects topology change, it sends the BPDU with TC flag enabled, and spine is the root bridge which receives it, and then it updates all other root bridges in the network by sending BPDUs with TC flag enabled. So that's what we were seeing it on the root port. Let me do one more thing. So what I'm going to do is I'm going to say uh, interface Ethernet 1 spanning tree cost. Let me do TCP dump again. Spanning tree cost. Now, as soon as I change this cost on ET1, there should be a convergence. There should be a topology change because right now ET1 is the root port. So if I increase the cost, then some other interface ET3 will become the root port. So leave 2 ET1, which is the root port, should send a topology change update to the root bridge. Okay, so I'm doing it. Yes, we can see that. We can see that topology change. We can see topology change. Okay, so now F340, which is the root port. So root port is sending topology change because I changed the cost on ET1. So there was again a spanning tree convergence and topology change. So whenever there is a topology change, root ports do send BPDUs. But in a normal scenario, the root ports do not send any BPDUs. They only listen to BPDUs, listen for BPDUs. But when there is a topology change happens, they send BPDUs with TC flag enabled. So that's very clear. So hope you were able to get some information on spanning tree root port election. So in my next video, I'll be talking about spanning tree designated port election. So see you in the next video. Hope and if you like the video, like and subscribe to my channel. And see you in the next video.